Alright, good day and welcome back to Genome Tutorial. I'm Nathan at ang pag-uusapan natin ngayon ay kung paano mag-compute ng flexural stress ng isang beam. Okay? Pero bago ang lahat, kung hindi ka pa nakaka-subscribe, mag-subscribe na at pakiclick na rin yung like at yung notification bell. Okay, I'm pretty sure na marunong na kayo or alam nyo na yung mga formulas na ginagamit dito sa flexure formula. Okay, we have problem number 1 here. It has a given figure, okay, with unknown RA and unknown RD with a cross-sectional area na rectangle na merong 120 mm by 200 mm. So, from the neutral axis, meron tayong 100 in both part. Or kapag hinati natin yung 200 mm, magkakaroon lang tayo ng 100 mm at 100 mm. So, ayun, the requirements here is to find the maximum bending stress or the maximum flexural stress in the given figure, and also to find to compute the bending stress at the point B that is 25 mm below the top, okay, below the top of the beam. Okay, this is the point B at pinapahanap yung flexural stress below the top of the beam. So, when we say below the top of the beam, babawasan natin ng 25 yung 100 mm support na to. Okay, if you are wondering kung paano nakuha itong 14 kN at 19 kN, gagamit lang tayo ng summations of moment is equal to 0. Let's say summation of D muna tayo. Summation of moment D is equal to 0. So we have RA, let's say that is X, okay, multiply by 0.8 plus 1.2 plus 1 is 3. Okay, is equal to, we have UDL na 6 kN per meter. 6 multiply by the total length na nako-cover nitong UDL natin. We have 3. Okay, multiply by 1 over 2. I mean 3 over 2. Or 1.5. Okay, plus the concentrated load na 15 kN. Okay, at yung distance ng point C or nitong concentrated load natin from the point T is equal to 1 meter. So, ayun, that's why the reaction at A is equal to 14. To compute for the value of RD, pwede tayo gumamit ng summation forces. Summation of forces is equal to 0. We have 6 kN per meter multiplied by 3. Okay. Plus 15 concentrated load minus 14 is equal to RD. Positive 19. So, ayun. Okay. The next thing na kailangan natin hanapin dito ay yung moment. Okay. Yung value ng moment at point B at yung value ng moment at the maximum or yung value ng maximum moment. Upon looking at the figure, makikita natin agad na sa point C yung may mataas na moment kasi doble meron tayong UDL na cover nitong concentrated load na 15 kN. So we have the shear and moment. Okay, I hope na marunong na kayo mag shear and moment. We have, papakita ko na lang ulit, we have upward or positive 14 minus, okay, from point A to point B we have UDL 6 multiplied by 0.8. We have 9.2, which is correct. Okay, minus from point B to point C we have UDL again 6 kN per meter multiplied by the distance between the point P and point C is 1.2, which is positive 2. Okay, minus 15 kN concentrated load, so negative 13. Okay, we have downward load again. We have negative 6 multiplied by 1. Okay, we have negative 19 at sa RD is upward na positive 19. So, plus 19. We have 0. Okay, I hope na nakuha nyo yun. Okay, for the moment, gagamit na lang tayo ng area method. Okay, from 0, we have trapezoidal. So, 1 over 2 multiplied by 0.8. Okay, multiplied by 14 plus we have 9.2. So that's equal to 232 over 25 or equal to 9.28. So that's the moment at point P. Okay, we have positive again plus trapezoidal again, the shape ng area natin. So 1 over 2 multiplied by 1.2. Okay, multiplied by 9.2 plus 2. Okay, positive 16. Okay, meron naman tayong downward or nasa ilalim naman na kaya negative trapezoidal pa rin. 1 over 2 multiply by 1, okay, multiply by 13 plus 19. Okay, we have 0. Nag-0. So, kapag nag-0, it is a good indication na tama yung pinagkagawa natin. Okay. Upon looking sa moment diagram natin, makikita natin dito na positive 16, yung pinakamataas na nakuha nating moment. So, ayan yung gagamitin natin sa flexural or the maximum flexural bending stress. Okay. Remember the formula for the flexural stress. We have, okay, flexural stress on the beam is equal to M multiplied by Y all over by the moment of inertia. Okay. This is the general formula. Pero kapag sa maximum naman, meron tayong FB max is equal to moment max multiplied by C all over by the moment of inertia. Okay, meron na tayong maximum M. Okay, meron tayong C, which is 100. At yung moment of inertia naman, we have moment of inertia ng rectangular is equal to base multiplied by height cube all over by 12. Okay, to compute the moment of inertia of the given cross-sectional area, gagamitin natin itong formula na ito at that is equal to moment of inertia is equal to base. We have 120 mm or 0.12 meter multiplied by, we have the height na 200 equal to 0.2 meter cube all over by 12. So yan ay equal to 0.12 multiplied by 0.2 cube, okay, all over by 12. So that is equal to, okay, 8 by 10 raised to negative 5. Okay, moment of inertia yan, kaya meter to the fourth. So FB max is equal to 16 kilonewton meter multiplied by, okay, 0.1, okay, meter all over by 8 by 10 raised to negative 5, okay, meter to the fourth. So, cancel out na natin isang meter dyan. Isa rin dito, kaya ito na lang natira. So, the FB max is equal to 20,000 kilonewton per square meter. Or equal to, okay, equal to 20 megapascal. So, yun yung maximum flexural stress, okay, located at the point C. To compute the second requirement at the said problem, which is the flexural stress at the point B, which is 25 mm below the top of the beam. Okay, we will still using the formula, okay, and with the same moment of inertia. So FB is equal to the moment at point B. Remember, yun ay equal to 9.28. So 9.28 kilonewton meter. Okay, kilonewton meter multiplied by the Y. So ang new Y natin dyan is 100 minus 25 since it is 25 mm below from the top of the beam. So multiplied by 75. Okay, 75 mm or equal to 0.075 meter all over by this moment of inertia. So 8 by 10 raised to negative 5 meter to the fourth. Cancellation ng mga meters. Ayan. So FB, okay, flexural stress at point B is equal to 9.28 multiplied by 0.075 all over by 8 by 10 raised to negative 5 is equal to 8,700 kilonewton per square meter. Okay, or equal to 8.7 megapascal. So ito na yung answer sa second requirement. Okay. Okay, I hope na nakatulong itong video nito at kung may mga katanungan kayo regarding sa aking solution, you are free na magtanong sa ating comment section. At kung hindi ka pa nakaka-subscribe, feel free na mag-subscribe at pakiclick na rin yung like at pakihit na rin yung notification bell. Goodbye.